The world of data orchestrators is a crowded one, with tools like Airflow, Luigi, Prefect, Argo, and Mage. My favorite by far is Dagster. And in this video, I'm going to walk you through its most important concepts. We'll look at how assets, jobs, schedules, partitions, and I/O managers fit together with code examples to create a highly composable and maintainable data pipeline. Within Dagster, the asset is central to everything. An asset represents a materialized piece of data. This can be a DuckDB table, a Snowflake table, a CSV file, an audio file, or even an in-memory arrow table. Let's start simple. Imagine a daily export of your Spotify listening history. Every report contains all your played songs and artists for that day. This works, but it's not a true asset yet. It reads data, but it doesn't store anything back. We want the data to persist. That is where I/O comes in. Dagster can persist data in multiple ways. The most direct is via a resource. A defined external system Dagster can inject into your assets. Here, we define a DuckDB resource once, and Dagster automatically injects it into any asset that declares it as a parameter. This makes resources reusable and centralized. However, while this works, it's not very composable yet. We still handle all read-write logic manually inside the asset. That's where the I/O manager comes in. An I/O manager is a layer of abstraction on top of resources. It defines a contract for reading and writing between Python objects and their materialized representations. Instead of manually interacting with the resource, we simply return the Python object, in this case a Polars data frame. The I/O manager handles the conversion between Polars and DuckDB. The beauty? Assets now become storage agnostic. Switching from DuckDB to Snowflake? Change one line. No refactoring. We can materialize assets manually from the Dagster UI. But we're still running things manually. Let's automate that. Jobs lets us define what selection of assets we can run as a single unit. Where a job defines what to run, an execution strategy allows you to define when an asset materializes. The most common execution trigger is a schedule. A schedule runs jobs on a time-based interval, often defined using cron notation. By default, schedules start disabled, but here we explicitly set it to running, so we don't need to enable it from the UI or CLI later. The second way to trigger jobs is a sensor. Sensors can monitor any pollable event and trigger jobs based on external changes. This makes Dagster flexible enough to behave like a smart orchestrator rather than a static scheduler. Now, let's tackle one of Dagster's most powerful features: partitions. If we process daily data, we don't want to overwrite the same table every day. We want to handle each date's data independently. Partitions let you process subsets of your data independently. The most common partitioning strategy is a time-based partition. Now each asset run corresponds to a specific date partition. Dagster automatically tracks which partitions exist, which succeeded and which failed. There's one last thing to make a partition work: telling Dagster how the target resource stores the partition key. Without that, Dagster cannot backfill or re-ingest correctly. The fix is simple. We add a partition expression to the asset metadata, so the I/O manager knows which column to use. With this in place, Dagster can safely rerun, backfill, or selectively reprocess any partition. And now, our asset is fully partition aware and production ready. You can even generate a schedule directly from a partition job. This automatically creates a daily run for each partition, without writing separate schedule code. At this point, we've gone from a single static CSV reader to a fully dynamic, composable, and observable pipeline, complete with assets, I/O managers, jobs, schedules, and partitions, all orchestrated by Dagster. Over the next few videos, we'll implement a functional pipeline that transcribes audio files from scratch. We'll also implement the medallion architecture, integrate dbt with Dagster, and use Snowflake as a backend. That is where the real fun begins. Please like and subscribe if you found this video helpful. See you in the next one.